Is everyone ready? Let's get ready for chemistry! Because of the nature of molarities, the quantity for a solution comes from its volume. If the two molarities are equal, then volume will stand in place of moles. There will be a direct correlation between the volume and the number of moles. So 15 mils of solution AB should be directly equivalent to 15 mils of solution CD. If these were acids and bases, we would expect 15 mils of AB to neutralize 15 mils of CD. Now, this is assuming that the ratio between the two is 1:1. If the ratio is not 1:1, then 15 mils of AB will not be equivalent to 15 mils of CD. If the equation is balanced with a 1:1 ratio, then this is true. Equivalent volumes will be equivalent number of moles. If the ratio is 2:1, however, it will take twice as much AB to be equivalent to 1 equivalence of CD. Therefore, instead of 15 mils of AB, it will take 30 mils of AB. So if the ratio is 2:1, it will take twice the volume. Therefore, we can use equal molar amounts of both and use equal volume amounts of both. We can use the equal volume amounts as equivalents to find the mole ratio between two aqueous liquids that will produce a precipitate. So I'll take one liquid and I'm going to measure out 15 mils. And I'm going to pour carefully but confidently. So I'll spill if I'm afraid, if I'm concerned, I'll spill. What I want to do is I want to put the thing I'm filling up down. I want to rest the lip of the bottle on the lip of the graduated cylinder. And I want to pour. Until the bottom of the meniscus reads 15 mils. Then I'll do it again. This will be the second thing. And so I'll add 15 mils. And I'll pour confidently, and that will make less of a mess. Since these are both 15 mils, if the ratio between the two was 1:1, then it should be an equivalent amount. So if I take the 15 mils of this and I pour it in here, bottoms up, and then I take the 15 mils of this and I pour it in here, what you're going to see here is you're going to see a precipitate form. And you can see how that's opaque now. You can't see through it anymore. That's evidence that a precipitate formed. Well, I mean, is that it? What's left? Were they equivalent? Or was the ratio 2 to 1, or 3 to 1, or 2 to 3? So what I need to do next is I need to filter this solution. I'm going to get a small ring clamp, one that just fits this long stem glass funnel. A long stem glass funnel is going to work the best for this. It's going to help draw the solution down the funnel. I'll put that on my ring stand. And I'll put it on there so that the ring clamp is pointing towards the base. So I want to filter over the base as much as possible. If I face this the other direction, if I put weight on the back here, the ring stand has the ability to tip back as I put weight on it. If I put weight on this side, it's harder for it to tip forward. So I'll put the ring clamp on there and I'll put the funnel on there. Normally when I do a filtration, I want to filter this into an Erlenmeyer flask. The advantage of an Erlenmeyer flask is it's harder for things to splash back out the top because of the triangular shape of the flask. So we'll use an Erlenmeyer flask. I'm going to bring the funnel down so that the stem, the bottom of the stem is inside the flask. Kind of like that. Now obviously there's no filtering going on here because there's no filter paper. So we need to put the filter paper in there. My recommendation for you would be to use 2 filter papers, flute one of them, and then keep the second one as a kind of doily. What you can do is you can put the individual filter papers each on the balance one at a time and then write on them in a pencil. The pencil ink won't smear. So then you write on them on a pencil. Watch the video for how to flute filter paper, and then you'll have one that's fluted and you'll have one that's flat. Because this thing is going to bleed solution all over the place. And if we don't want it dripping all over the place, then we'll want to have a doily under it for later. So we'll take our filter paper that's been fluted, and then we'll put that in the funnel, and it fits in the funnel, and there's ridges, and it's all ready to go. And then we'll take our precipitate. We'll want to swirl it up before we use it. We'll want to mix it up. What we want to avoid is we want to avoid the precipitate staying in the beaker. We want the precipitate to end up in the filter paper. So we'll swirl it up and then we'll add it to the filter paper. If the solution overflows the top of the filter paper, we'll have to filter it a second time. So it's very important that we are patient and that we don't fill up the filter paper to the point where it overflows the sides of the filter. So you can see here, the filter paper is doing its job. It's got some of the solution in there. The funnel is dripping into the Erlenmeyer flask, and this is going to take a little bit of time. As the solution drips into the flask, the level in the filter paper will drop, and I'll be able to add more, being careful not to fill it so much that it overflows the filter paper. I've still got some precipitate in the beaker, and it's starting to get to the point where it's getting stuck to the sides of the glass. So this is where swirling is going to become super important. Now I'm filtering pretty quickly, and I'm very happy with the speed at which this is going. the little drop that's left behind, I can touch that to the filter paper and that will suck it off of the edge of the beaker. You can see here, there's still some precipitate left in the beaker. We need to wash that out of the beaker and into the filter paper. While I could wash the beaker out with deionized water, it might actually be better in this case to wash the beaker out with the filtrate. So this is the precipitate, and this is the filtrate. This is the precipitate, and this is the filtrate. The filtrate is what came through. And you can see that this is nice and non-opaque. It's transparent. None of the precipitate made it through the filter paper. So what I'm going to do, since this looks to be pretty done, is I'm going to take this and I'm going to pour it back into the beaker. I don't have to use all of it. I'm going to go for a second round here. I'm going to swirl this up because some of the precipitate got stuck on the side of the beaker there. So I'm going to give it a second go. I'm going to swirl it up, and then I'm going to try to dump it in as quickly as possible. And if I didn't use too much, hopefully I won't overflow the filter paper. And I did use too much, and if I had gone all the way, I would have overflown the filter paper, and that would have been bad. So I've still got a little bit left behind, but I got a bunch more this time. So maybe this next time I'll be able to get it all in there. I'm going to kind of swirl it up and down the hatch. Still a little bit of precipitate there. Going to want to try it again. At this point, you know, though, kind of getting a little impatient. So I'm going to grab a DI wash bottle and I'm going to tilt the beaker and rinse it into the funnel. So I'll just tilt the beaker over the filter paper and then rinse this in there. And you know, I think I got most of it. The filtrate still looks pretty clear, so I'm confident that I didn't overflow the filter paper at any point during that process. Now we'll just wait for this to drip too. If I use too much deionized water when I do this, it will take that much longer the next time I try to filter this. I can see that the solution is still yellow, so I'm going to go for a second round. I'm thinking that this needs a second equivalence. So the ratio wasn't 1 to 1, more than 1 to 1. I'm not going to add more yellow. I'm going to add more of this stuff. Another 15 mils. And we'll see what that does for us. But I want to give it time to finish dripping out of the filter paper. All right, that's looking pretty good. So if we touch the bottom of the funnel, it'll help suck the rest of the liquid out of the bottom there out. Then I can take my filtrate, I can dump it into a fresh beaker or back into the original beaker. My second aliquot, my second 15 mils is all ready to go. So I'll mix these together. And that makes a precipitate. And I will need to filter this precipitate. question is, should I use the piece of filter paper that's already in there, or should I go back for a second piece? The pores of this filter paper are pretty clogged by the precipitate from the first reaction. If I try to reuse this, all of the precipitate will be in the same place, but it might take significantly longer for the filtrate to make it through the filter paper this time. So what I'm going to do is I'm going to call this one. I'm going to get my doily paper, and I'm going to pull out, I'm going to pinch the filter paper closed. I'm going to pull this out, and it's all drippy and wet, right? So I've got my doily underneath it. And then I can carry this to the drying oven. So I'm going to set this aside. I'm going to grab 2 more pieces of filter paper, fluted, ready to go. We put it in. Take my beaker, swirl it. We don't want the filter paper to overflow. And you know what? Now that I'm looking at it, I've already messed this up. What I should have done is I should have rinsed the flask into the beaker with some DI water. I should have rinsed the flask and dumped it into the beaker to get all of the yellow out that didn't move over when I dumped the flask into the beaker the first time. If I had done that, I would see the filtrate is actually colorless this time. All of the yellow is gone. Which makes it look like a 2-to-1 ratio is equivalent in this lab. So these two solutions had a 2-to-1 ratio because all of the yellow is gone. This claim is going to be substantiated or not substantiated by the mass of precipitate that I'm collecting. If the ratio really is 2-to-1, then the mass of this precipitate should be the same as the mass of this precipitate. I want to keep this as full as I dare. The extra weight of the water will help it filter faster. But again, I don't want to overflow the filter paper. The solid is remaining behind in the filter paper. The solution is ending up in the flask. I've got a little bit of reddish brown on the sides here. I want to rinse that down with DI water. That's a mistake that I made with the flask that I'm not going to make a second time with this beaker. This beaker contains the precipitate. If I didn't rinse it down, that would be an experimental error. So there's still precipitate in here, and I want that precipitate to end up in the flask. And you can see that's not nothing. Can rinse down the walls of that. And I'm pretty sure I got all of the precipitate out of that beaker. Now I simply wait for this to finish. As this finishes up, I have my doily for the second filter paper, and I want to label it with my name because I'm about to put it in the drying oven over the weekend. And anybody who sees this, they're going to want to know that it's mine. So I'll write maybe my name or maybe my group color, possibly the period as well. And if I write in pencil, it should be fine. And you know what I can do is I can write the mass right on this as well. So if you take the mass of this and the fluted filter paper at the same time, you can just write directly on your doily paper. You're going to have the mass of the unused filter papers, and then you'll have to have the mass of them when they are dry. So it looks like we've gotten all of the filtrate out. It's time to grab this and pull it out. Put it on our doily. And the doily immediately starts getting soaking wet. Now we're going to take these and we're going to put them in the drying oven. My precipitates are looking pretty good. And you can see how the grooves in the filter paper caught the precipitate. So fluting the filter paper was important, allowing it to get through. So I'm going to take these and I'm going to put these in the drying oven. They're soaking wet. I need to get rid of that water. The drying oven is latched. It's a little hard to get open. If you give it a good yank, it should open up. You don't want to yank it out of the fume hood though, that would be bad. So there's some shelves in there and we'll want to put our precipitate in the fume hood, and then we'll just close it. And it had to give it a good yank to get it open, so we'll have to give it a good shove to get it closed. And then overnight, we'll turn the fume hood on, we'll let all of the water evaporate, and when we pull it out, our filter paper should be fairly dry. Now what to do with my filtrate? Because these are heavy metals, and because heavy metals are toxic, nothing can go down the drain. We cannot dump anything out down the drain. We can't throw anything away. That's where the hazardous waste jug comes in. So everything needs to be rinsed into the hazardous waste jug. Now we don't want to use a whole lot. We can just rinse this in. And then we're ready to scrub this out with soap and water. And then do a final rinse with deionized water. But all of the solutions in the lab need to go into the hazardous waste jug. And then all of our precipitates and filter paper as well, as soon as we know we're done with them. Everything generated in this lab has to go in here. Nothing can go down the drain. Nothing can go in the trash can. All right, the next day, it's had a chance to sit in the oven overnight, so I'm just going to open up the oven, and I'm going to carefully reach in here and I'm going to pull out my precipitate papers. Kind of don't want to touch anything too much because it's an oven and it might be a little hot still. And now these are all dry and ready to be put on the balance to find their mass with no water present. And you can see the doilies did their job. They kept this from dripping all over the place. And once I have the mass of these, it's time to get rid of them. But instead of throwing them in the trash, I have to put them in the hazardous waste jug. So we'll just toss these, stuff them in there, right into the hazardous waste jug.